Hello guys, this is going to be a part 4 of a better power supply design for audio amplification. So basically we are using different reference from J. Randy Sloan book. So this is one of the part of the circuit of the power supply. You can see we have the fuses to protect the amplifier. And also I noticed that on this bridge rectifier it used 2 fuses, but I think 1 fuse is just enough. 1 fuse should be just enough just to protect the transformer in case something really bad happen. That fuse is going to blow and it's not going to damage your expensive toroidal transformer. Remember, it's the bridge rectifier is basically a solid semiconductor, and the semiconductor short out is going to damage the transformer. So it's good to have a fuse at least on one single rail on one of the winding. As you can see, we have the winding here, and we only need one. It's not really needed to have 2. I think so. One winding protection is good, this one here. So we had the power supply almost complete. I had to spend a few hours yesterday. I was really tired because I have think that I needed to isolate some areas of the snowbird capacitors, and I spent a few hours doing that yesterday, so I was really tired. So, and then this is I'm going to show you the illustration that I did just to make sure that right now the orientation of the cap, they are not going to be in that position. They are going to be upright. They are not going to be in that. I just placed the cap there just to see how it's going to look. The dimension of this cap is 12 millimeters. That's why I create a macro with that dimension just to see how it's going to look like. I think it might touch the heat sink, but I think that can be easily fixed with just a spacer. You can use a aluminum spacer to place the heat sink, but I don't think it's a big deal. Maybe you can bend it inside, maybe away from the bridge rectifier. I don't think it's a big deal because the bridge rectifier edges are this one right here. This is the edges of the bridge rectifier. So Mr. Stewart sent me. I read his notes today, and he sent me the actual correct simulation for the LED indicator. So we need to find space for the LED indicator because we are going to use 2 of those, and then I gotta delete this. It's okay. I can place those back again. So we need this space to place the circuit. So we're gonna need 5 components for each individual fuse. So we need to find space. I gotta do some tricks here not to have a way too large components here. So we need 5 components to be able to do that. So okay, on the simulation I found out that it's working good. I like it. It works really good. So basically what I did, I just copy the same circuit ones that we have, 1 for each individual fuse. So we had the fuse 1 and fuse 5. So what I did, I just placed a switch, a temporary switch. It's not a temporary switch, it's just a switch that you can open and close with the letter A, and also I edit this one here to letter B, so I can how you call it, I can open and close to simulate that the fuse is blow up. So right now, if it's connected to the fuse, if the fuse blows, the LED will turn on, so that will indicate that there is a failure on the fuse, or the fuse is not doing his job. So that's the idea right there. So right now, this is the whole schematic. As you can see, we have the 2 bridge rectifier, and we have the fuse that will protect the bridge rectifier in case something really bad happen, and the other one here to protect the other BR2, the bridge rectifier 2, BR2. All right, so we have everything. I have everything figured out here. I just copy and place. Mr. Stewart, he did already the circuit. I didn't do the circuit. That's Mr. Stewart circuit. All right, so I'm going to turn on the simulation, and you will see that okay, we have the voltage is correct. We got 62 volts, and we have 62 volts negative. So we have 62 positive and 62 negative. That's what we need for the honey badger. So basically, for some I'm going to simulate like a fuse 1 blow up, and you will see the LED turns on. That's a good indicator that the fuse is faulty or is open. Basically it's open. That's the best way to say it. So right now I'm going to press the letter A on the simulation, and you will see that the LED turns on, giving you the indication that the fuse is faulty or open. So right now I'm going to press A one more time, and you will see that the LED is off. So that's a good indicator, as you can see. And then on the other one, I can one sample separate the failure. One sample is the simulation still on, so I'm gonna press the letter B, and you will see that the fuse, I mean the LED will turn on, giving the status that the F5 is open. So the F5 is open, so that's good to go. So I'm gonna press it again. So the bottom one is the negative rail. So this is the negative rail right here, and I'm going to do the same thing. I have the letter C for the fuse F7. So I'm gonna press C, and you will see that the LED turns on. So that means there's a fault. It is a open fuse. F7 is open. So I'm gonna enable it one more time, and I'm going to simulate F6, the fuse 6, this one here. That will be the letter D, and then I'm gonna simulate it. Let me just make some adjustment here. So letter D, and as you see the LED 3 is on. So that giving the notification that the fuse F6 is open. So basically I can make the labels. I can identify the LED, and also at the bottom of the PCB label fuse 7 or fuse 1, whatever, depending on which is connected to which. For example, if I'm going to do the notification for the fuse F1, I will place F1 on underneath of the PC. One sample, I'm gonna show you how right quick. Let me yeah, what happened here? Okay, it's not too big. That's weird. Okay, so let me rotate it. I want to show you right quick. I think that the font is too big. I'm gonna make it smaller. Okay, there you go. So that's a LED 1, and then at the bottom I will place a F1. So this will show you a notification that the F1 is bad if you see that this turn on the PCB. So I think I might be able to accomplish fitting those components. We need 5 components, so I gotta figure out how to place those components. So we need 5 components for that individual circuit. So it's 5 components right here. We got R10, we got diode 1, Q1, LED, so it's 5. It's basically 5 components. So I gotta look for this part number and create the macros for those individual components. So I gotta make one circuit first, and then create the other one. So I gotta start to place those components here. I need to have plenty of space, so I might have to move some stuff around just to have enough space for the rest of the circuit for each individual component. So I needed to give it some space. So the notification is this one here, LED 1, and then I will place the information of which fuse is blow up. So that will be F1. So I'm just gonna label F1 here. I gotta make it smaller, it's too big. Let's go with 1.5. I think it should be correct. 180 degree. There you go. So this is F1. So this is the notification of the fuse. If that LED is on, so we know where to look for. Okay, it's F1. So let's go to F1 to fix it. To fix that. This is this one here. Basically this one here. Yep. It took me a long time, but about the capacitor, the snowbird cap, it took me a long time to figure out, because I had to isolate some areas of this design, so to make sure that I don't have to short out. So one example, this is the filtering a snowbird cap. Oh yeah, I gotta identify those particular fuses. One example, you can see the cap it's filtering this one here, and then it's going to be connected to this one here. So this is one diode, and we have the other connection here that you can see it's isolated, and you see that it's not going to be intervening with other components. So I spent a few hours yesterday doing that. Believe me, spent a few hours. I was really tired. So okay, but after the PCB is complete, I had to check it with the 3D software just to make sure that everything is correct, all the connections are correct before we continue. So I gotta make the circuit for each individual fuse. So I gotta do it. So we need to figure out I need to figure out how I'm going to place all those components there. So it might take some time. It might take some time to do that. But I have a lot of patience, so that's a good thing about me. I do have a lot of patience. So okay, there you go. That's a F5. That is an excellent idea. An excellent idea. So we had each individual fuse with a indicator failure indicator, or open fuse indicator. That's a good stuff. All right, I'm gonna stop this video. I don't want to make it way too long, so I gotta work with the LEDs indicator, and I think this is an excellent idea. All right, guys, have a good day. I hope you like this video. This is part 4. We'll continue to part 5 after it's complete, just to show you how the PCB is, the final look of the PCB, high power amplifier power supply, basically. Now this is version 2.0. I had to change it, so we need to be sure that it's 2.1. so I gotta save it, save as 2.1. It's a good thing that every time we change the version, we save it into another file. In case the file is corrupted, we still got the backup of that particular file. So it's a good thing that we do in this way. All right, guys, have a good day.